Welcome to this video, which I hope will help explain these topics regarding Java totals and something called Sentinel data when you're dealing with loops. Very quick review. It seemed that most of you have the pattern about the loop structures pretty much down pat. I'm dealing with a computer where I've got Windows 7 and Windows 8 that like to fight each other, so hopefully this doesn't become annoying while you're watching the video. These are three different loop structures that will produce a pattern of numbers. I hope you can see this on the screen. In this first example, they all do the same thing actually, and this is not, well, it is a complete program. What I've done here is I've taken this while loop. The starting value, just very quickly, the starting value is 4, and as long as the value in memory is less than or equal to 13, it's going to print that value out, and it's going across the screen because of the word print. The value changes when this says value plus equals 3. It changes the current value in memory to 3 higher, so the 4 changes to 7. Now that's in memory. The computer then loops around because of these braces right here. As long as the value is less than 13, it prints out to 7. It prints beside of it because it says print and not print line. The value increases by 3 again to 10. 10 is still less than or equal to 13. It prints the 10 out. I hope you got the routine down pat. The new value in memory increases by 3 because of this statement I'm circling. It changes to 13. 13 is still less than or equal to 13. If I didn't have the equal there, it would stop. But it prints 13. The last number in memory increases to 16, but when it gets up to the top, 16 is not less than 13, and that's the pattern of numbers that prints out. The very same thing happens in the next routine where I've got a do while loop. The same 4 numbers print out, and the same 4 numbers print out in the next routine. Just going through the 3 different kinds of loops that you've already seen: the while loop, the do while, some people just call it do, and the for loop. And that's just some very quick review for you. If you leave out parts, get the greater than, less than over, sometimes this makes a difference. Now we can use these loops for other applications, and again, I'm just following the worksheet that I've given you online and I wanted to show you this due to time restraints. I'm doing a lot of stuff that is not necessarily literally by the book, but you can refer to the chapter in the book if you need it. In this particular program, a grade is typed in at the computer, and the while loops make sure that the grade is more than 100. It basically, it's like taking a video game and being sure that it's robust enough that if you do something crazy or quirky with it, that the program doesn't crash on you. So if you're looking at this particular program on the worksheet, you may want to have this worksheet downloaded or printed or whatever so that you can look at it. I'm using the scanner class where this will allow me to type something at the keyboard. Now I've actually done, I've actually done a sample input over here in this text box. A sample or example of the running of the program is right here. This is not the way it runs every time. It depends on what you type in. You'll notice that I've declared a variable right here that's called grade. There's nothing there right now. And then I have 2 sets of sentences that are totally identical. Right here we have an input method. Remember, with the scanner keyboard, this is, by the way, something referring to an object in a class called scanner. The keyboard allows me to type something in, and then that value is assigned to the grade variable. Notice these 2 sentences that are in yellow. They're right here where I've got the blue marker, and right here we have something outside of the while loop. The while loop is the most powerful of the 3 structures that you've been exposed to in the last exercises. And you'll notice that those same 2 statements are in there. I've got one on the outside, and what it does first, it says type a grade from 0 to 100. That's my instructions. And let's suppose that I type in the first time, let's suppose I type in -5. -5 would go in memory. And what happens when I type in -5, I look at this while condition right here, and here's what happens. -5 less than 0, yep. And that's an OR statement right there, the little double lines. And if I put in -5 greater than 100, one of those is false, one of them is true. But what it's saying is, as long as the grade is less than 0, or as long as the grade is bigger than 100, that loop will execute. And because the -5 is less than 0, that's true, So what it does, it executes this set of sentences, and it says the grade -5 is not valid. Try again. That's what I get right here. And what happens, because this is a loop, it goes right back up to the top of the loop. Now it doesn't go outside the loop, it stays inside this while structure. And I know this is getting messy, which is right here. And it allows me to type in the next grade from 1 to 100. Alright, I chose to type in the number 113 for this next routine. This is the next running of it. If I type in 113, 113 gets placed in memory. And let's test the while loop again. The while loop now says 113 less than 0. No, it's not. 113 greater than 100. Yep. We said again, as long as the grade in memory is less than 0 or one or the other, greater than 100, which it is. So this time it's not less than 0. 113 is not less than 0, but 113 is definitely greater than 100. So while this guy is false, this one is true. So again it says, oops, 113 is not a valid grade, try again. It keeps on going through the loop, and you can type any numbers you like. This time I typed in 76 for the value for grade. And just to keep this from being so cluttered up, pardon me, I'll make this a 76 now. If I type in 76, here's what happens. I'm going to erase this so it's not so cluttery. The 76 is placed right here in the while loop, and it tests it out. 76 less than 0? Nope. 76 greater than 100? Nope. The while loop doesn't work, so what the computer does, it skips over the while loop because both those conditions are false. It skips the while loop and it checks it out. In other words, it's checking out that this is a valid grade. So now what it does, it looks at the 76 in memory. It never got down here for the other two numbers. If 76 is greater than or equal to 70, and it's true, it does this statement that says you passed the test. Had I typed in something like 40, 40 is not greater than 70, it would have printed out you failed the test. So I hope this explains this particular validation program. It's basically just using a while loop to see whether the information typed in is legit, whether it's legal or not. In the second program, instead of testing out values, well, we could test out values. What's going to happen here is we're going to type in a bunch of numbers to add together. Now again, this is a machine. I'm sorry that this program keeps bouncing back and forth for you. I'm trying to get this leveled on the screen, and sometimes it gives me a jump on the screen. Let's see if I can get this to stay for you. Alright. Think of this as being a calculator. I keep having to adjust my headphones. I apologize. Keep thinking about this as a calculator. I've got two variables right here that I'm using, and I'm not inputting them this time. I've got a variable called value and a variable called total. Think of this like a calculator where I have a running total. I'm starting out with the initial total equal to 0. I'm starting out outside the loop. Here's the while loop right here. You'll see that I use the while loop more often than not because this is the most powerful one. Outside the loop, the value of value is 4. So here's my total equal to 0. Here's my value equal to 4. Alright, as long as the value is less than or equal to 4, or less than 14, and 4 is less than 14, that's true, it's going to print out the value, so it prints out 4. And then we have a statement right here that says total equals total plus value. This is the way your pocket calculator works. You're simply taking the current number inside of value, which is 4. You're adding it to the current value of total, which is 0. So that new value, when I add 0 plus 4 together, I get 4, and that final number, that addition, is stored in this variable. So the 0 gets replaced by 4. In other words, so far, a 4 has been typed in the calculator. Now, we're going to change the value one higher. Value equals value plus 3. The new value of value is going to change now to a 7. The loop continues and it tests it out. And let me erase some stuff so it doesn't get cluttered. While value is less than 14, well, the new number is 7. 7 is definitely less than 14. Since it's true, the loop continues. It prints out the 7. And again, here's what happens with total equals total plus value. The current number in the value cell is 7. The current value of total is 4, so I'm adding 7 to the current subtotal. So 4 plus 7 is 11, and the variable now changes to an 11. In other words, that 11 is a combination of the 7 and the 4, so it's added those two numbers together. The next number that's created in the loop is 10. In other words, it's the same loop. It's generating the numbers 4, 7, 10, and 13 that we had in the earlier program, except now we have a new statement in there. Instead of just printing them out, we're doing a subtotal. So 10 is the new number. 10 is still less than 14. That's true, so we keep on going. We print out the 10. There it is right there. And again, here's what's happening. I'm taking that 10 and I'm adding it to the current subtotal, which is 11. That gives me a total of 21, and 21 is the new subtotal. 21's the sum of the 4 and the 7 and the 10 that were put in there. The new value becomes 13. And again, the loop is tested out. 13 is still less than 14, the while statement right here. So the 13 is printed out. The 13 is then added value to the current value of total. So it's 21 plus 13, and that's a new total of 34. So again, what I've done is I've taken the numbers 4, 7, 10, and 13 and added them together. And you're thinking, oh my gosh, well, how does it kick out of it? Well, what happens is the new value of value, sorry to be redundant there, is going to be 3 higher. So the new value last here will be 16. You're going, oh my gosh, 16 doesn't print out. And you're correct, because when it gets up to the top of the loop, it tests it out by saying, okay, is 16 less than 14? That's false, which means that the loop stops. Now when the loop stops, it's kind of like bypassing Kings Mountain or bypassing Charlotte on 485. It goes around the loop and starts with whatever's after the braces. And it prints out the statement, sum of numbers is, and the value total is not in quotation marks, so it looks for it in memory, and the value, oh, excuse me, I don't want to use that word, the number contained in the variable called total is 34, and that's what prints out. So this is the way that you basically do addition or totaling of numbers with a loop. I'm going to flip back up to the top of the page and show you this just to let you know. The difference basically is, and I'm going to erase this stuff so it's not cluttered, basically you're taking the number pattern that you're used to seeing and you're just tacking on an extra statement in there that says total equals total plus value. Instead of just printing the numbers out, you're adding them together. You want to be sure to declare total as a variable right there and set it equal to 0. So you're basically not doing much difference to the programs that you had before. You still have the number pattern going that you've seen in the previous worksheet. Now you're putting an accumulator or totaler in there. You can do that with multiplication also, except instead of putting total equals 0, you would put total equals 1, because if you multiply by 0, of course, nothing will happen. And third program I want you to see is I'm doing the same total situation, but instead of having a pattern, I'm going to put in just different numbers. So again, it's very similar. We did this before, and hope you stop this video if you need to go through and process this a little bit more. I've used some different variable names this time just for a changeover. Here's the word number. Here's the word sum. Sum being set to 0. This time I'm going to have the number typed in at the keyboard. And notice these identical statements are both inside the while loop to keep it going and outside the while loop to get it started. We want to have a number that we type in, and it says to type in -99 to quit. So let's say for the first number, here's the example of the output right up here on the right hand side. It says type a number -99 to quit. Suppose I type in 7. The 7 will be put right here in memory, and it does a test right here. 7 does not equal to 99. What it's saying is, as long as 7 is not equal to 99, 7 not equal to 99, that's a true statement, isn't it? 7 is not equal to 99. Thumbs up, true. So it will execute the loop. and I've got a sentence that's very similar to what I had in the previous program. Instead of using total and value, I'm using sum and number. I'm taking number, which is 7, adding it to the current value of sum, which is 0, and I store that subtotal in the variable called sum. So the sum so far is 7. And the computer will ask me right here to type in another number. When I type in the next number, I'll type in a 12. 12 becomes the new number that's in memory, and it goes to the top of the loop. Here's the loop right here again. Here's the loop. And I'm looking at 12. Is 12 equal to 99? 12 is not equal to 99. That's still a true statement. As long as 12 is not equal to 99, negative 99, sorry, it will execute the statement. What it does, it takes that 12 that we've just put in and adds it to the current value of sum. Now what's already in there, the subtotal of 7 is currently in there. Again, think calculator. So when you add those two numbers together, you get a total of 19, and that 19 is stored in the variable called sum. So now this becomes 19. That's the total of 7 and 12. It asks for another number, negative 99 to quit. This time I'm typing in 45. So let's change all these guys to 45. 45 is the new value for number. Before it goes through the loop, it tests it out and says, okay, is 45 equal to 99? That's what it's testing out. 45 is not equal to negative 99. That's true. So what it does, it takes the new number, which is 45, adds it to the current value of sum, and the current value of sum is the 7 and the 12 that was put in before. That's 19. Adds those together, and that subtotal, which is stored in the variable called sum, is now 64. Gotta do my arithmetic right. It's late. Alright, now it asks me for another number to type in, and this time I'll type in negative 99. So in memory, number is going to be negative 99. Now sometimes this next part confuses people. The while loop is tested. As long as the number is not equal to negative 99, and here's the way it looks at it. It says negative 99, that little exclamation point means not in Java. Negative 99 not equal to negative 99. That's a false statement, isn't it? They are equal, so that statement is false. Because it's false, it skips out of the loop and goes outside the loop to the very first sentence, and that's what prints out the final total, which is in the variable called sum, namely 64. Hopefully this helps you understand it. The difference between this program and the other one, this program I can put in a different set of numbers kind of randomly, if you speak, where in the earlier program the for loop generated the numbers automatically for me. That's the difference in them. Last of all, we want to look at a different kind of loop or a set of loops, and these are called nested loops. It just means one loop inside the other. You can refer to these in the book, and I will give you some page numbers in just a minute that you can refer to, or I'll actually give them to you on Blackboard because I don't want the video has a little more permanence that way. In any event, I'm looking at the nested loop, one loop inside the other. What I want you to see for right now, and I'll undo this in just a minute, I will take this program, which I hope you can see on the screen, and you can look at it on your worksheet as well. What I'm going to do is take out, there's going to be a slight pause in this video while I get a light turned on, because I'm recording this from home and the headphones keep sliding off my head, and that's why you're hearing the noise. I so very much apologize for that. Basically what you have is one loop inside the other. What I'm going to do at the moment is I'm going to temporarily take out some sentences and let you see this loop by itself. If I were taking this one all by itself and just doing this part, and thank you for bearing with me as I do these videos, which are not very fancy, but they serve the purpose. If I had this loop right here and did it, what would happen is, and again I'm just trying to make this easy visually because people are such highly visual learners, this is a loop that counts from 1 to 3. I think you see the pattern right here. It goes 1, 2, 3 and prints out a star for each one. So this loop all by itself would print out 3 stars if I did it that way. That's just one basic loop. What's happening now, we have something called a nested loop, and it deals with rows and columns. This is a very good example for doing number patterns. Now you're going to see some crazy stuff happen on the screen in just a minute. I'm going to do this undo button to get everything back where it was. It's going to look very crazy until I get it in there, so you're going to think, oh my gosh, what happened to my computer screen? There's my, I think that's my original program. What I have now, instead of just printing out something, what I have on the inside now is a loop that goes 5 times. This goes 1 to 5. You can think of it this way. Think of a roller coaster ride. And in that roller coaster ride, I've got 1, 2, 3, 4, 5 rounds. So that what's happening, for every round I go on the roller coaster, I have 5 small loops. And then when I get to the next round of the roller coaster, round 2, I've got 5 loops going. And when I get to round 3 of that roller coaster with the purple, I've got 1, 2, 3, 4, 5 patterns going. So here's what's happening. That's the reason that I've got it this way. The outside loop is 3 rows with 5 stars in each row. Here's what happens. The value of x is 1 right here. And what happens, while that x is 1, this loop right here goes 5 times. Y becomes 1, then 2, then 3, then 4, then 5. And every time the Y loop executes, it prints out a star. So it essentially prints out this first row of stars. And you may be going, oh my gosh, I've got the word print. Well, why does it not keep going across and just keep going star, star, star forever? The reason that it doesn't do that is as follows. Once these 5 rounds are over, I then have, and I could have done this another way, I did system.out.println, which is just a blank line. What happens basically is it takes the marker and simply drops it to a new line on the screen. So what happens next, the value of x now becomes 2. And while x is 2, the Y loop starts completely over again with 1, 2, 3, 4, 5. So think of it as the second row, and this time this row prints out. Once this loop has been executed, I have the system out print line that drops me to the 3rd position. X now becomes 3, 3rd round. I'm going to make this a different color so it'll stand out a little better. X becomes 3, and Y starts over as 1, 2, 3, 4, 5. So again, for every round of X, there are 5 rounds for Y. So hopefully you would know what would happen if I wanted to have 8 rows of 2 stars each. I would change this 3 to an 8 for 8 rows. And if I wanted 2 stars on each row, I would change the yellow one to a 2, and that would be 8 rows and 2 stars on each row. So it gives you a way to generate patterns. There are other applications for this that you can use very beautifully, but we don't have time to do this in the short period of a 14-week online course. It's so much easier when you can teach it face-to-face, but online it's a bit more challenging, and that's the reason I wanted to go through this with you. Please be sure that you do the worksheet exercises that follow on this same sheet. Hopefully they'll help out for you. If you type these into Java, you need to understand that some of these are just parts of programs. For example, if you were to take this first one and run it in Java, you don't have the main routine, you don't have the complete program there, it's just a little subset. You can do this if you like, but hopefully you will learn from these patterns. And I'll have a couple of exercises for you to do on the book also. If you have any questions regarding this worksheet, please contact me.